Okay, now let's get to Lesson 3, Composition of Functions. So what this means is that we are going to put, let's look at this picture and see if we can explain it. So what we're going to do is we're going to take g of x and we're going to put g of x into f of x. And then that is what composition of functions means, is that you put, well, that means if you have f of g. If you have g of f, then that of x, then that means that you put f inside of g. So what it means is that the second function goes inside the first. Okay? That's what it means. So let's get to some examples. All right? So for part A, we're going to find f of g of x. And all we're going to play is a substitution game. So that means f of g of x by definition. So from here to here is the definition. And then, so g of x is x squared. So this is f of x squared. So that means that it's the square root of x squared plus 4. And that's all we can do with it. And if we want to find the domain, because it says find the domain of each of these functions, the domain of this is negative infinity to infinity because this thing is always positive. All right? So for part B, we want to find g of f of x. So that means g of f of x, and again we're playing a substitution game. So that is g of the square root of x plus 4. So that means that we want to take the square root of x plus 4, square it. Well, that means we get rid of the radical. So this is just x plus 4. All right, so what we did from here to here, this is, I'm going to do this up here. So here to here is the definition. Here to here is substitution. Here to here is substitution. Here to here is simplification. Now, if we want to find the domain here, the domain again is going to be all real numbers, because we can put any real number in there and still get a function. Okay? All right. So now let's look at this one. So for part A, we want to find f of g of x. So that's f of x times g of x. So that's f of x to the 6th. So that's x to the 6th to the 2/3. So I'm going to go right over here and I'm going to multiply 6 over 1 times 2/3. So that leaves me 2, which is then 4. So this is simply x to the 4th. All right? So from here to here is definition. From here to here is substitution. From here to here is substitution. And from here to here, I simplify. All right, so now let's look at part B. So I want to find g of f of x. So that's g of f. So that's the definition. So that's x to the 2/3. So that's substitution. So this is now going to be x to the 2/3 raised to the 6th. So that's substitution. And from here to here, I'm going to simplify. And that's going to give me x to the 4th because I know that it's still going to be 4 because I can multiply. And in both of these cases, my domain is negative infinity to infinity because they're both strictly polynomials. Now, I want you to notice that both A and B are the same. All right? Right? That means that the function is onto, and it's a very special case. Okay? That the two functions are. Okay? Hit the wrong button. All right, now let's look at 31. Okay? So let's look at f of g of x. So that's f of g of x, which is f of x plus 1, which is 3 over x plus 1 squared minus 1, which simplifies down to being 3 over x squared plus 2x. And so my domain, so here I have x squared plus 2x equals 0. So x cannot equal 0 or 2. So my domain, negative 2, is negative infinity to negative 2 union negative 2 to 0 union 0 to infinity. All right? And for part B, I have g of f of x equals g of f of x, which is g of 3 over x squared minus 1, which is 3 over x squared minus 1 plus 1, which that simplifies to x squared plus 2 over x minus 1, x plus 1. So my domain here, so x cannot equal negative 1 or positive 1. So my domain is negative infinity to negative 1 union negative 1 to 1 union 1 to infinity. Okay? All right. So now, where this is used the most is in making word problems. So now what I want to do is I want to make a word problem that is a function of x, where x is a function of t. All right, so part A is I want to make a c of x of t. So this is c of x of t, where c is the cost, x is units, and t is time. So c of x of t equals c of x of t, which equals c of 50t, which is 60 times 50t plus 750. So my cost in terms of time is 3,000 t plus 750. So what this means is that cost as a function of time, right? So it's cost per hour. Is what you're trying to find. Okay, so what they're wanting you to do is the cost. So they're wanting the cost of units per hour. Okay, because it's C of X is the cost of units per hour, is what C of X of T means. So B says find C of 4 B says find the cost when t equals 4 hours. So that's find C of 4. So that's 3,000 times 4 plus 750. So that's 12,000 plus 750. So that is $12,750. So after 4 hours, the cost is $12,750. And part C is asking you to find the time elapsed in order for the cost to increase to $1,500. So cost equals 15,000, then T equals, we don't know. So you're going to set 15,000 equal to 3,000 T plus 750 and solve. So that's 14,250 equals 3,000 T. So 475 equals T. So what does this mean? Well, the 4 is 4 hours, and the 0.75 is equivalent to 45 minutes. All right? Oops, I'm out of page. So when the cost is $15,000, then the time elapsed, or the elapsed time, will be 4 hours and 45 minutes. Now, this is a good example of why I want complete sentences, because the complete sentence tells you that you understand the entire question. All right? Because it's asking you find the time that must elapse in order for the cost to increase to 15,000. So the time elapsed must be 4 hours and 45 minutes. All right? So